Should we give it another minute just to let some people wake up and arrive?
Yeah, that sounds good. When I'm unmuted, can you guys hear my crazily blowing laptop fan? Or is it okay?
It sounds like you're like next to the equipment room of a hotel swimming pool.
Well, I hope that gives you a nice mental image then. Yeah, I don't know what it is. I'm not running anything, but Firefox is really sort of not liking Miteco very much. I'm like at 98% CPU on one core.
Bitcoin mining. Should we get started then? Yep. Okay. Hello all. Welcome to the quick working group meeting session for IETF 110. If you're not meant to be in this session, please leave the room now while you have the opportunity. This is a virtual session. We have today 3 chairs just to help lift the load. So Matt is our new chair to come on board and help take over from Lars as he transitions away. I'll let Lars maybe speak to some of that in a bit more. But yeah, we've got quite a busy agenda today. Lots of presentations of adopted items with a few, as time permits stuff, which we can come on to in the agenda bastion in a moment. But yes, where are we? This is what we're looking like for now. We did have some hackathon activity during the last week, and Lars is going to give an update of that, I think. Should probably try and open up the slides ready for this. And in terms of administrivia, we don't need to do blue sheets today because Miteco will do it for us. We have a scribe in Robin Marks, but if anyone would like to dive into CodeMD and help him out, that would be fantastic. We should bring up the note well, just in case you're not familiar with it. We are partway through the week now, so you should be probably familiar with this, but this details or is a good entry point into detailing how you contribute to the IETF, including lots of stuff around patent policies, or importantly our code of conduct, and how you interact with the group and participate. So if you're not familiar, please go away and look at the note well, get yourself familiar with it, and understand that this is how the IETF and the quick working group in the IETF like to do things. So go back to the agenda. Where are we? Fellow chairs, do we have any other administrivia items that you would like to talk about? No?
Not really.
Okay. Great. So,
I'm going to ask if anybody wants to bash the agenda, I guess.
Oh, that's a good point. So let me scroll down a bit, just to give the full view of the agenda. So to go through them in just a little bit more detail for people, we've got equal balance of time for presentations from the different adopted items. So the ops drafts, manageability and applicability slides. Then we'll have Tommy talking about the datagram slides, the datagram extension. Then David talking about version negotiation, and finally Martin with the quick LB stuff. We think the quick LB might be a little heavier than the others, which is why we put it at the end. But yeah, we'll try and get through those things, and then we've got possible presentations from Martin or Jana about their possible things we might want to adopt before moving on to some planning and wrap up. So the question is to people, does anyone want to bash that agenda?
So stepping in here, Magnus Westlund. The recharter, did you have that on the agenda?
No, we don't, because there's nothing really to do for us at the moment, right? We have a charter proposal out. I've seen one suggestion so far come in that was like an editorial change that is easy to make, and I guess the call for feedback from the communities, you know better than I, Magnus, another couple of days.
Yeah, you have until the 18th to provide feedback. So that's, I guess, is for general knowledge that if you please review the external, the latest charter text version, and if you have any feedback, provide it by the 18th.
Yeah, and maybe it's sort of the summary is that sort of the quick working group changes its format a little bit. It's sort of now that we've finished version 1 of the documents or the base drafts, we sort of changing gear, and the HTTP part, QUIC and HTTP, we're handing over to the HTTP BIS working group for maintenance. We are continuing to maintain the other documents that we have, or will soon publish. We're also going to maintain operability and manageability documents and related ones. We are going to maintain the extensions that we're going to have worked on already. We're going to do new extensions. Those may or may not be in support of higher layer protocol bindings to QUIC. I guess the sort of the thinking is that if you want to layer a protocol on top of QUIC and you require a complicated extension to do that, that extension we probably would want to do inside the QUIC working group. If you need something very straightforward, you can do that elsewhere in the IETF together with your binding or even outside the IETF. So this is sort of a summary of what's written down in the charter in more detail. If any of this is surprising to you, you definitely want to read the charter text and comment on it.
Thanks for that. I think we can move on.
The other thing I'd like to add, in case anyone's missed it, is that the core transport documents have been pushed through the IESG, thanks to Magnus, and all the efforts of everyone involved in the review process and addressing the feedback. So if anyone's looking at this agenda and wondering why we're not talking about any issues on those documents, it's because effectively they're done. There's still some work to do in terms of Auth48, etc. kind of changes, but yeah, we've updated some of the guidance on the base drafts repo just to say, like, we're not accepting anything now. We're done here. We're ready to ship. We need to go through the process, but please don't come along and open issues about it would be nice to have this or that. If there's fundamental problems with the protocol, security issues, or major editorials, we need to involve the whole community in the IETF, not just this working group. And together with our responsible AD, we'll be able to do that. But yeah, please take this seriously, because the ship is going. It's almost over the horizon, so we can be very grateful. But I'll be quiet for now.
Yeah, one quick addition. I talked to the RFC editor the other day, and the expectation is that we will see the first batch of these documents pop out into Auth48 in a time that's sort of measured in weeks and not months. So it's going to be reasonably soon, since the queue over there is pretty short. As you guys probably know, the HTTP-related documents, HTTP and QPAC, are waiting for some work in the HTTP BIS working group to complete. So those two won't be part of this initial batch that comes out, but all the other documents, which are, let's see if we can figure it out, invariants, transport, TLS, and recovery, those 4 should come out in a matter of weeks.
I mean, the next item here is the Hackathon Report. I don't know if you want to take that up, Lars.
Yeah, so the hackathons have become quite a bit, not that they're virtual, they have become quite a bit less busy than they used to be. And maybe that's because I'm sort of in a time zone that's not where most everybody else is. But also the spreadsheet looks pretty empty at the moment. Part of that is because we are sort of just switched over to using version 1. And not all stacks have sort of made that change yet. And also a lot of the interrupt testing is now actually happening in an automated fashion all the time, thanks to Martin Seaman and this interrupt runner. And so there you have a bit more green, which means implementations that already support 0x1 as a version. Wherever you see only red, that means basically that implementation hasn't updated their image yet to speak version 1. And I expect that'll become more green over time. We have Christian in the queue who wants to speak about that. Go ahead.
Yes, Lars, one thing that did happen during the hackathon is the perf interrupt, which you want to mention.
Part of that, so if you were, please mention it.
Pardon me?
I did not participate in the perf interrupt. So if there's anything to mention, if you did, please mention it.
Yeah, I mean, basically about five implementation did a performance interrupt that was driven by the MS Quick team at Microsoft, and did measurement of performance of Quick basically in a variety of scenarios, but mostly download and upload. And the great news is that all those implementations achieve speeds between 1 gigabit per second and 5 gigabit per second. That is with just software implementations, no hardware assist. And the interesting news is that the same implementation achieve performance between 1 gigabit per second and 5 gigabit per second, depending on circumstances, which means that we still have work to do there. But that's quite interesting. It shows two things. As you said, I mean, the hackathon is moving from basic stuff like verifying that everybody can do zero RTT to performance, like verifying that everybody can hit several gigabits of performance. That's one part, so it's maturity. And the other thing which is interesting is that this shows that the work done by the various operating systems to make UDP work better is starting to pay off. I mean, a year ago, those performance would have been about 500 to 600 megabits instead of 1 to 5 gigabits. And so the difference is because, I mean, there have been work done in Linux and in Windows to make UDP faster with things like UDP GSO. And that is paying off. That means that the operating systems are in fact adapting to Quick, and that's good news for the working group. Over.
Thanks, Christian.
I think we're ready to move on to our main agenda items. So, Miria, would you like to join the queue and I can pull up your slides?
Yeah, actually, Brian is presenting this.
I apologize. I assumed because you've been doing all the work, Miria, that you would be presenting.
No, it's me doing all the work and Brian presenting. Also, you just did misspell my last name in the agenda, but no worries.
Apologies. Get that fixed for you.
So I guess I can go ahead, and I don't really actually need to be in the queue. I can just go ahead and start sending, apparently. Hi, I am not Miria Gudevant, and I will be talking about the operations draft, applicability, and manageability. Next slide. This TLDR is mainly for people who are not here today, so they can tell whether they need to look at the slide deck or not. Mainly, thank you all very much for participating in the working group last call. It turns out that the working group last call does, in fact, get people to read and reread documents. So thank you for participating in that experiment. The TLDR is we think that we're good to go with applicability with some changes that we're going to be discussing today and making soon. We might need to do another working group last call on manageability after all the changes are merged. So we're going to talk about a couple of open issues with input. A couple of things might need text. We're going to talk about those right now. So next slide. A recap, updates in revision 10. A bunch of editorial changes in both documents. Thank you, everybody, for all the reviews. A few content changes that are primarily editorial or slightly more than editorial. The big one here, I think, is a new section on ICMP handling. So if you have not This is number 249 in the manageability draft. So if you have not had a look at revision 10, these were mainly editorial, mainly sort of like small fixes before this meeting. However, there are some changes to the content. So please do go have a look at those. Next slide. So we've got some open issues with proposed PRs. A couple of things creating short sections that we did want to bring to the attention of the working group and get some discussion on. One, adding some text on datagrams. This is number 273, addressing 269. The main reason we want to bring this to people's attention is that it changes the reference structure of this document, right? Like, so it's a PR discussion and extension. It's the first time we would discuss an extension in these operations drafts. However, since this is now a milestone of the working group, it seems like it's a reasonable thing to point to. There is a recommendation on ACking and reducing the ACK rate on constrained links, which we believe is ready to merge. Please do go have a look at number 233. If you have opinions on ACK rate constraint, we'd like a couple more eyeballs on this. We will intend to merge that one relatively soon, so speak now. There's an open issue. So we've basically talked about, there's been some text going back and forth on the use of probing packets in order to actually start getting information into a congestion controller about the capacity of a link. This is, I think we had a different term for this at one point. It's currently being called in this PR priming the CC. There are questions as to what does priming the CC. I think we called it preheating at one point. There seems to be some going back and forth in the terminology here. We'd like some input here on whether we should change the wording or whether it's even important to say this. We believe it is as the editors. But if we can't find a term that is clear to people, then we could consider removing entirely. Next slide. Moving to manageability.
We have Gory in the queue.
Gory, go ahead.
Oh.
If the audio works, but maybe it does. Cool. I'm not sure we need this text, which is my main comment on that issue with the primer CC. If we don't say it, we can still do it, and in future we can specify it. If we say it here, I think we really need to be careful. We explain what prime means, that somebody has looked at the CC implications of doing this badly, and that we give appropriate advice. And I'm not sure we're in the position to do those last two.
Cool. So that's a good way to address it, is to punt it to the future.
Happy to listen to other people if they think there is advice on those.
Let me reply to that. So the intention here really was just like to mention what probe packets can be used for. This is kind of a list of things, and this is like one potential use of probe packets. I don't think we're at the position where we want to like recommend a specific algorithm or whatever, because we don't have one. But I think it's still a good use. It's still something that can be very valuable in future. And I would like to have it in here. I would just like to keep it mentioning as it is without like having a detailed explanation how to do it. But if it's not clear what it means, it doesn't help, right? So I guess we might not only want to find a different word, but maybe add another sentence if we keep it.
Christian?
I mean, I think that this is not really ready for prime time, this priming. I don't think that we have a whole lot of implementation experience with that. So at that point, that is speculative, and I would rather not have speculative text in something that we are going to publish.
Gory?
A kind of making it more bland, like say, assist in determining the congestion controlled state for a new path, or help in, and just not hint at what the mechanism might be, and then we're open to do whatever work we want to in the future as another possibility out of this.
Yeah, I guess we could actually just say that like probing packets can actually be padded with padding data and therefore also increase the congestion window without saying much more.
Right. I think that's the reason we do want to have something here, is to sort of like provide a hint, you know, so people don't have to independently reinvent this as they're trying to get data into the congestion controller. So.
Yeah, and there was a comment in the chat saying this is kind of internal and not really something that the application can impact. But I think the reason why we mention it here is because some of the applications might want to actually impact that. So you might want to consider if you can provide any kind of interface for it, because it might be more important for some applications than others.
It sounds like we've got enough input on this topic.
Yep.
So move on to the next one, Brian.
That was what I was going to say. So now moving on to manageability. We've had some discussion on the text on UDP timeouts. Previously, the document was citing, I think, some work that Lars did about 15 years ago on the distribution of UDP timeouts in the internet, saying we want to be longer than that 30 seconds, which is everywhere. And now we have we're pointing to recommendations in RFC 4787 that says, you know, not less than 2 minutes for most UDP traffic, and please go above that. We believe that this is the right, most recent advice that we want to give. You know, we also understand that like there's, you know, 2 minutes is what we're saying in terms of timeouts on the endpoints. There's 30 seconds in the network, so there's a little bit of a difference between the advice and what's widely deployed right now. But we do think that 4787 is the right recommendation. So if people have other input on that, please jump on to PR 222 before we merge it. We've also added the proposed section on so guidance for Path Mtu. So this is guidance that essentially says, you know, please drop a large QUIC packet rather than fragmenting it, so that QUIC gets the feedback that it needs to adjust its MTU. We've got a lot of review and wordsmithing already on this one. We believe it's pretty close to ready to merge. If you are not aware of this PR and have opinions about MTU probing with respect to the network treatment there, please jump on 212. The NAT section has been rewritten to minimize text. There was some redundancy in there. It hadn't actually been had a very fine editorial comb on it. Now it has. It is an editorial, or at least the intention is that it's editorial, but it's huge. So more eyeballs on that one before we merge it would be good. So on to the next slide. We have a few minor issues on keep or remove that we wanted to raise attention to. There's currently a line about the fact that FF was used as a prefix for IETF draft versions, which references previous text in the transport draft. I think about that, which has now been removed from transport. There's a question as whether we want to keep this around as a pointer to sort of the historical state of there are implementations out there that might still use this this convention, and here's what they mean. So there's an algorithm in 244 for basically figuring out which QUIC version you're dealing with. This was, there's stuff in section 9 that talks about the algorithm, and then there's like, you know, pseudocode in the appendix that goes into more detail. There's a request in this issue to remove the text in the appendix. However, it might be helpful for the community, so we'd like more input on that as well. Again, please, in the bug, that's number 244.
Just like what section 9 is the appendix with the algorithm.
Oh, did we not fix? I thought we actually merged the thing where that is now actually Appendix A, but okay, so
yes.
Oh, it is the appendix. Okay.
But the issue was there before.
Right, got it. So yeah, do we want to keep this or not?
Magnus wanted to say something, I think.
Yeah, I have a comment on 279 on the versions.
Oh, okay. Yep.
think it might be simpler if we actually get the previously used draft versions into the registry, the official registry, and then we can actually point to that, that these were draft versions, those that were actually used.
So those are FCFS, right? Like, so we can basically just send an email to Ian and it's done.
Yeah.
Okay. Yeah, that also, that would be.
Wasn't there a discussion that people don't want to do that? I'm not sure.
There has been some discussions back and forth, and I don't know, so that's maybe more of to have feedback on this, but it's.
Martin wanted to say something, I think.
So getting all the versions we know about into the registry should be relatively straightforward. We can just do a quick poll. We can scrub the wiki that we have, and I think we're in the process of appointing experts for those registries now. So we're not quite at the point where we can take those things, but we should be able to have that in time for this document to be published.
Okay, perfect. Then we can just point them.
That sounds like that one's resolved. Yay! Thank you, Magnus, for stopping me through my race through this document. And then a third bit on connection ID requirements. I believe that this was originally before these were tightened up. This is older text, I believe. Before these were tightened up in the transport document, we wanted to have some text here. Now it essentially just repeats what's in the transport document. So is there a need to repeat the requirements to obscure any encoding that are already in the transport document? So that's a keep or remove. If you have an opinion there, please go talk to us on 243. I got one more slide, and then we'll use balance of time to go back and talk about any other questions. We do have 2 open issues for which we would really, really, really like to have some help from authors. So endpoint cooperation on DOS mitigation. So basically, you know, how talking about how a DOS classification could be done with knowledge that comes from the server on your endpoint about at least connection ID links, if not connection ID data. So that would need, we would need text on that. If there are authors who would like to help us, please jump into 240 or just assign it to yourself. Same with respect to our recommendation to tell middle boxes to ignore the version. So there's a request to basically, you know, take this text and put more information in about why we'd want to do this, right? Like a motivation for allowing upgrade as opposed to thou shalt. So that's on 178, also seeking authors for that one.
Yeah, I think on 178, it's really also about what's the recommendation we actually want to give here. Like the current recommendation is stated here, but the issue was also about, is that the right recommendation? Do we need to change this? And then like, what would be the new recommendation? So this would really helpful if more people could look at this and comment on this.
So to the last, oh, go ahead. Gory has a comment on this.
Yeah, I may have been a part in both of these, perhaps, and I'm still interested in finding the right answers here, because these are actually 2 tricky ones from where I live. The last one might be more to do with the whether it's a constrained environment or an enterprise or a different deployment context to which many people are thinking about QUIC. So that if we think about them in that context, maybe we get a bit more view. If anyone is willing to try and provide text, I'm certainly willing to help contribute.
Okay, cool. You were talking about 240 or 178 or both? You're talking more about 240, correct? The endpoint cooperation on DOS mitigation.
Yeah, but maybe also it's 178. The situation where you control those boxes may be very different for an enterprise.
Right.
in the way they think about this. So mainly 240, but now I see also it's perhaps the same for 178.
Cool, Miria, let's assign both of these to Gori.
Yeah, so Gori, if you could just,
I need seriously.
No, I mean, if you could just like try to write something down, because I think if you write something down that people disagree with, that would like bring the people on the table and actually say something. So having some text is better than having no text.
Sure. The reason we're talking about it here is because we will need eyes on this, because this is something we need consensus on, not one opinion.
Right.
Okay, we'll do something.
Cool. So Gori, we can sign you up to get us started on that. Excellent. Thanks so much. So that brings us to the end. You can go and look at the last slide, but it's basically, you know, step 1, merge PRs, step 2, question mark, step 3, publish. So again, I think I haven't heard anything here that changes our estimation that we are definitely ready sort of after we close the last issues on applicability, but well, ready like post WGLC, we're ready to send it up. We'll have to look at what comes out of the resolution to the issues on manageability to see if there are enough changes to ask for another working group last call or not. I guess how much more time do we have to discuss this? Like any other comments, questions on these, or do we need to move on?
Is there something really important? You might have like a minute, but beyond that, I think this gives a good picture of where we're at, and we've got some people signed up to help guys keep tracking that handle. So there's other editorial issues on those documents as well. So if people feel inspired, please check it out and get involved, I would say.
Cool. All right. Thank you very much.
Thank you, Brian. Let's move on to the next slide, which is Datagram.
All right. Good morning and afternoon, everyone. All of you people in Europe are making me feel more tired, I feel. Okay, so we'll be talking about Datagram here. This is one of the adopted extensions we have, and I'll be presenting on behalf of our co-editors. Next slide, please. All right, so the status here is, I think we're in pretty good shape. We have, looking through the issues list, I would say 4 substantive open issues. That's the ones that we want to discuss today. There are a couple other editorial issues that you can go and look at on the GitHub. And I want to highlight that this work is actively the basis for what's going on in the MASC and web transport working groups. So please, you know, if you're really interested in this stuff, if you go there, you'll have all the time you want to argue about the details of how you use datagrams, and those are very active. And I want to highlight also that MASC has been doing interop testing. It did that last week during Hackathon, so we have 4 or 5 plus different implementations doing interop with datagrams and application work on top of datagrams. So I think we now have a pretty good experience using this, and we're in a place where we can hopefully close out the issues and make good decisions about them. And our milestone currently is to have this shipped off to the ASG by July, so I think we can do it. Let's just try to converge on these issues and get it shipped. So next slide. All right, so jumping right in. Thank you for resizing. So I'm going to go, in interest of time, through the 4 issues, hopefully in order of least to say to most to say and discuss. We do have one of our open issues is a eternal topic that keeps coming back, and this is the current iteration of it. Issue 6, talking about why don't we have any flow IDs at the quick transport layer. And this has been something that's been discussed since before this was adopted, since the very earliest discussions. We've had versions with the flow ID, versions without. We currently do not. I think every time we come back to this, eventually we get to the point where we say that, that there is no transport level function of a flow identifier of a datagram if it does not influence any flow control, any behavior like that at the transport layer itself. Currently, the text in section 5 does explain that applications can define their own demuxing. It kind of gives the example of how HTTP3 is doing that with a flow identifier currently. The question keeps coming up. I do believe that overall the discussion has consensus that we are doing the right thing, but it seems to me from the issue that what we want to do is kind of end up with an editorial change to just really highlight and make clear what you should do if you need to do demuxing. One of the suggestions was essentially just to pull the current text in section 5 into its own subheading so it shows up in the table of contents. It's its own section 5.1 that explains that, if you need identifiers, you can define them in this way, and it's purely application semantics at that point. So what do people think about this? See, Eric.
Hector.
Yeah.
So I mean, I just want to I'm not advocating for one thing in particular, but I think it'd be useful to lay out what the costs of this position are and the benefits. The benefits of the position is you're not to carry any machinery in this draft or in your datagram implementation if you don't need flow IDs. The cost of this position are one, sort of document mechanics, which is if you want flow IDs, you have you have to have a document, which largely probably means H3, H3 datagram. So you have an extra little document shim in between in between your document and datagram, which is not a big deal if you're using H3. And then if you're not using H3, then you have to make a new thing that looks like H3 datagram, maybe by copying H3 datagram and crossing out H3 everywhere, right? And those are the costs and benefits of these two positions, correct?
Yeah, and just to highlight some of the conversations we were having in Mask where we're working on H3's use of datagram, we're still trying to converge there about, what does this identifier mean? And I think, we're even calling into question, is it really a flow identifier? Is it more of just like an application label on a set of messages? So I think, yes, there is, it puts a bit of burden on the application, but it also gives the application a lot of freedom to define what it wants to put as this identifier. And it may even be that HTTP3 won't strictly use it as a flow identifier, that it may be out of something more broad than that. I think that's one of the reasons really not to put it here.
Sure. Yeah, I'm not objecting to that. I think that the perhaps one way to resolve this issue would be, as well as making the sort of changes you make, to make a what best way to put this, to have a section that explains this a little. I mean, I guess you already have one, but point to H3 and basically say, if in future we determine that essentially a zillion uses of datagram. So I mean, so from my perspective, if everyone uses H3, it's a total non-problem, right? And if everyone uses H3, they can just point to H3 datagram, and that has a flow ID and some mission accomplished. And all I like to do is have two sites instead of one. And if there turn out to have a lot of applications that want to do datagram and want flow IDs and don't do H3, then all we need to do is clone H3 datagram, cross out H3, and have a new draft, and they can point to that, and it'll be the same sort of notional stack of documents, and problem will also go away. So I think maybe if we try to and the cost will really be one new extension, right?
Yeah, and what we can do is highlight that looks like H3 will use a VLI here as the first field. That's a convenient thing to do if you want to do your own extension, but it's up to you to negotiate what that means.
Yeah, exactly. So I guess I'm just I think that what I'm suggesting is that if we give people a slight roadmap for how this would look in the future, if we had to solve this problem, then maybe the tension to solve this problem will actually go away.
Perfect.
Thanks.
Gory, are you in?
Yeah, Gory, did you mean to be in the queue? Or? Well, okay, David, I guess.
Yes. No, I just wanted to say that the most of the arguments we've heard from folks about wanting flow IDs sounded like they wanted to multiplex multiple applications over QUIC. And that was intentional. Well, that was discussed in this working group and intentionally ruled out of scope for QUIC v1. And so, like right now, you only have one application, and it's identified by your ALPN. And so, like once I think folks realized that, they like wanting this at the transport layer became less useful, whereas having it at your application makes total sense. On the topic of folks wanting to use this, the H3 Datagram document has about like one paragraph, which is, hey, the Datagram starts with a flow ID, and then the entire rest of the document is about how you integrate this with HTTP3. It's about the setting, it's about how you negotiate it in a very HTTP specific manner. Right now, for example, it uses an HTTP header. If another application wants to use this, we don't need to like clone or split off a document. They can just write a sentence like us, which is, the Datagram starts with a flow ID, and here's what a flow ID means in our application, and here's how we negotiate it. So like I don't really see the value in centralizing this. All that this is the payload starts with a flow ID, and having each implementation say, my payload also starts with a flow ID sounds really simple and easy. So I would argue to like keep the flow ID at the application layer as opposed to the transport layer.
But I think just spelling that out, like Ecker was saying, is fine.
Omer, did you have something?
Pretty much has summarized what I had to say. One thing to add is that if at some point in the future there will be more identifiers, then a new RFC can emerge to provide best practices. But if for now the best practice is put one integer, then that's it.
Yep. Sounds good. Thank you. Okay. So I think we have a direction there. We'll make a PR for this, and we can send that out to the list and make sure there's eyes on it. All right. Next slide, please. I think this one should be very easy. So in this issue, it was pointed out that we could do well to clarify a datagram's relationship with loss recovery. It doesn't specifically say what to do if there is suspected loss of a packet that only contains datagram frames. And technically, that is something that is just, there is already a default behavior, but we would do well to specifically say that. And so the consensus on the issue seems to be like everyone agrees that a packet with only datagram frames should be treated like any other packet. And so if a implementation detects loss or has the PTO, then it should send a ping frame in order to kind of kick things off again. Does anyone have any issues with that, or should we just go ahead and add a little bit of text?
Martin?
Martin.
A little bit why you think that a PTO is necessary in this case?
Sorry, I missed the beginning of that.
Oh, can you explain a little bit why you think a PTO is necessary in this case? I think I understand why, but is there a succinct explanation you can provide?
Let me. Do some of the people who are on that issue want to chime in?
Jana?
I see some loss recovery people.
Jana? Yeah.
Did you just call me a recovery person, Martin?
Well, you are the editor of the draft, dude.
Doesn't make me a recovery person anymore. It makes you a quick person. Anyhow, this is not that PTO is required. It's about what to do if a PTO is triggered. So the point here is that datagram packet is lost, no ACKs are received. You're not going to retransmit anything. We've seen this problem before in transport, and that's kind of the point. Is that just deal with it the same way we do it for packets that we typically in QUIC do not retransmit. That's really the point here. And if you don't have anything enqueued, if you want to evoke an ACK from the other side, then you send a ping frame.
Right. So this is what the recovery draft specifies, but what benefit does that provide? So say you've only ever been sending datagrams that you don't care to repeat. What possible value is there to that? It's probably related to the bytes in flight and all of the other loss recovery machinery, right?
It's the cleanup stuff. I mean, we've gone back and forth on this, and honestly, I'm trying to page in some of this because the discussion happened here almost a year ago on this particular issue. But I think that the two positions you can take are, we won't do anything if there's nothing to send. Basically, what happens is if I don't have an ACK, but I have nothing to send, then I can't receive an ACK back from the peer. I just have to take conservative steps and say that maybe there was loss. I'll cut back the congestion window after a certain period of time has elapsed and do all of those shenanigans. Or you say you probably should just send a ping, evoke an ACK, and do your math here based on accurate data that you receive from the peer. I would say the easiest thing to do is to send a ping. That just tends to be in most implementations, that tends to also be the easiest path forward. If somebody wants to walk.
We lost your audio.
Lost your audio. It's your headphones.
It's Mitako.
There we go. Ah.
Can you hear me now?
Yes.
Mitako thankfully informed me that my audio was disconnected for some people. But they reconnected again, so I'm grateful. So yeah, I mean, those are the two options as they've been. In transport, we've taken the general stance of saying, please send a ping so that you can do your math correctly. Unless there's a reason to do it differently here, I would just stick with the same. That sort of
okay. That makes complete sense. This slide made it look like this was special new behavior that was involved, and I think that's what triggered me.
The idea is do not try to make a special rule, because it doesn't seem to be clear that there would be particular benefit from going out of your way not to ping.
Yeah.
So some explanatory text there would help. Thanks.
Yeah, exactly. Thank you.
Ian, did you want to add any more color as a?
I was going to suggest that if it's not already referenced, I would probably just reference the appropriate section on recovery and say, like, Datagram does like what recovery already recommends. Here's like a level description, and yeah.
Yeah. Alrighty.
We have
Good.
10 minutes left for this presentation, so unless people have got any more points on this topic, I think we could move on and then try and keep any further comments brief, just so we've got time to get through both of these issues.
All right. So next one is a bit more fun. The issue around, how do we actually negotiate the support for the datagram frame? Currently, there is a transport parameter, and it is a max datagram frame size. And so this is specifically the size of the entire frame here. There's a proposal and a PR to switch this from a max datagram frame size to a max datagram payload size, such that you're only talking about the actual data that's contained within the frame and not any of the length fields, the length or type field here. It's effectively the same, you don't have to, it's whether or not you take into account the variable length integer at the front. Currently, if you have a 0 set in your max datagram frame size, that means that you do not support the datagram frames at all. We do, I think, want to be able to support sending 0 length datagram frames. So if we switch to datagram payload size, then 0 would presumably still be a valid datagram support, and you would only be able to send empty datagrams, which is a bit weird, but sure. On the issue, there's also discussion of, do we actually need any limit? Can we just say, I support datagrams? Personally, I can point out, like, in our testing and usage of it, we just set the value up to a very, very high value, such that it's always larger than what could even fit in a UDP payload to begin with. So yeah, I think this is a fairly open one, and Ecker is in queue. Ecker,
Thank you. I was trying to figure out, like, I mean, why would you want to say I only support datagrams of size 0?
Yeah, I don't know.
I mean, so remind me. I mean, isn't there another indicator that says I support datagrams?
No, this is it.
This is it.
So,
this is it. Okay.
So you could just switch it to be I support datagrams, and it's just a Boolean. The question is,
right. I guess what I'm saying is like that we're, I mean, so I mean, right. So you can say I don't support datagrams by not sending this at all, right? And
exactly.
And so, and there's no, and the way you say like I don't care about size, as I assume to offer like FFFF or something, right? Is offers like ginormously large number, right? And so, I mean, I guess the question is there a reason why you might wish to say, like, so I guess like the cool question is, there's a reason why I wish to say I support only 0 length datagrams, and is there a reason not to let you say that?
Right. I think it's fine if we say that, you know, the only way you say I don't support it is just to leave off the transport parameter, and all values are then valid. I think partly the question is, does anyone actually intend to use a limited datagram size? I think for H3, the use cases currently may not require that, but it could be useful. Yeah. David?
Just to explain the reason that right now 0 means not allowed, it's to make implementations easier. And in general, all of the other, all of the core spec variant transport parameters in QUIC have a default value. And so making a default value of 0 here, it makes it easier to implement. That way you say, oh, if I don't receive it, I set it to 0, or if I receive it with 0, it means the same thing. And that's why they're like this in the spec. I totally agree that we could change that to mean different things. It's just that makes it more of a pain to implement, because now you need UN64 and a bool, or, you know, a sentinel value, yada yada. Again, not complicated, but this is just easier. And then on the topic of, go ahead, Eric.
But now I'm confused, because it seems to me that now 0 and not present have different semantics, because 0 means I only support empty datagrams, and not present, and then not present is crazy semantics, because like I mean, like, if you don't send this, then we all agree if you don't send the extension, you can't send datagrams, right? I mean, like, that's like that has to be the case, right?
Yes.
Well, yes, and right now sending 0 means the same thing as not sending it. That's like the first dash in the slide right now.
Because like, it's not like having a 0 frame size means you don't have a frame.
Right, so, but I understand what you're saying is that if we make this apply only to the payload, then those semantics will be lost, and now we have a problem. Isn't that what you're saying?
Yes.
That or we disallow, or we say 0 is a special case. That 0 doesn't mean you can send empty frames. 0 means you can't send anything. But yeah, that becomes kind of ugly.
Well, I guess I certainly don't think that like I mean, just ignore it. I mean, it seems like there are two kind of like annoying issues here, right? One is like it's annoying to have to like take into account the variant size when you figure out what you're allowed to send. And so like that seems like motivation. That's Tommy says that's motivation for making this change. And then that just comes with this annoying implementation issue that you indicated, which is now like it's annoying to implement the extension, right? Not. I mean, I guess I think I'm a little less persuaded by the the default versus default value argument than others might be. But So I guess, if I have to pick, I guess I would say like, fine, like, zero means the stupid thing, which is you can only send zero-length datagrams. And I think we could also forbid. Do we have anything else that has a minimum? I thought we had things that had forbidden minimum values too.
We do, like the max UDP payload size transport parameter is not allowed to be under 1200, for example.
Right. Right. So that would also allow you to resolve the default value issue that you indicated, David. You say one, the minimum value is 1, but the default is 0 or something, right?
Yeah. I mean, my code has like for each thing a minimum, default, and maximum, but the default has to be within the bounds of minimum and maximum.
Right. I'm not sure there's any way to.
For time, I think we have Nick in the queue. Can we hear him and then move on to the next issue?
I would say that's probably it for this one.
Yeah, and then the last 10-second thing I'll say is because this is kind of deployed in running code in a bunch of places, I would be inclined to keep it as is, because if we change it, we'd have to renumber the transport parameter, and we already have a nice 1 byte value that would be nice to keep.
Yeah, and it's also, I think it's, since we've done a lot of interop, it's not that painful to do. Nick, can I have a quick word?
Yeah, I just wanted to go back to what you were saying about, do we really have a reason to limit the size beyond the packet size already? There was some discussion on the issue, and I never saw a good reason to actually have the limit at all. So my personal preference would just be to have a enable, disable the feature transport parameter and leave it at that.
Yeah. Okay. That's good to know. I think then I would kind of lean towards saying we either leave it as is, essentially as an escape hatch for future applications to limit the size if they want to, or we switch it to a Boolean essentially. So we'll continue that on the issue, but this has been very useful. Thank you. Next slide, very quickly. Last one is conversation around application events. The current text says that the quick implementation may notify the application when a datagram is act as a convenience. The issue is opened about asking what happens if the receiver drops act frames before actually delivering them. And this essentially raised the conversation around who effectively owns the buffer of incoming datagrams, quick or the application. And the suggestion in the issue, and I think my preference would be to say that, conceptually, once you have received a datagram, you've enacted, it is kind of between that quick implementation and the application to ensure that the application doesn't unknowingly drop it. So either you immediately deliver it up to the application and the application owns the queue of datagrams, and if it runs out of space, it can drop them. Or if Quick is doing that for you, it has to let the application know that it ended up dropping some packets because it ran out of room. So there's no case in which you silently are losing datagrams, but telling the other side that you have processed them. David.
Just added some, just wanted to add some implementation experience here. So in web transport, we use datagrams. And in particular, in the implementation, the quick stack and the JavaScript that consumes the web transport datagrams are not in the same process in Chrome. And so the application and the transport here are running in separate processes, and there is no synchronous interface between them. Everything is asynchronous. And so there is no possibility of, like, the quick stack is not going to wait for an asynchronous call to the application and back before it can act the datagram. That would be a huge implementation complexity that really we don't want to add. But then your proposed resolution of it must tell the application
if it drops before delivering.
So the thing is, like with datagrams, you don't want infinite buffers. And if your application is like busy or for some reason not like there's going to be a queue between the transport and the application. And if the application isn't pulling fast enough, like we don't want that queue to grow unboundedly. So that queue can have loss. But saying you must tell the application that something was lost, how is that useful? Because if I drop it, it's to save memory. I'm not gonna, oh, I was gonna drop it. Let me save it here in the list of dropped things. So you would just flip a bit and say, oh, by the way, I lost something. Like, what is the application gonna do with that? That's not useful, right?
I think if the conversation in the issue was saying that if you have at least a way to query, like, did you drop any packets for me? Like, just as metadata here, that would allow the application level, if it needs to do any application level signaling, depending on what, let's say it's doing video frames or something, and it wants to do a reset because it realized it had a big loss event and it lost a ton of frames, or it is missing something, that it can do application level signaling back to the other side to request a retransmission.
So thanks.
Can I interrupt here? We're at time. So I see Nick in the queue. If he has something very short after David, that's okay. But the queue's cut, and we do need to move on.
Yeah, I'll keep it very short. My opinion here is that we already have all the ACK mechanism at the transport, and it was very sad to hear that we really couldn't leverage that an application has to build their own their own acknowledgement path on top of it. It makes sense that for implementations that do queue, that's practically going to be required. But that's also an assumption. Like, for instance, MS-QUIC does not queue. It's an inline indication. So for us, it was easy to support this, but I was sad to hear that other implementations, it was not.
Yep. Same page. All right. Thank you, everyone. I think the next step for us is just we'll send out PRs for all of these things and then get input on them. Thank you.
Thanks, Tommy. Next up, David.
All right. Good morning, afternoon, evening, middle of the night, everyone. My name is David Skenazy, and I'm going to be talking about quick version negotiation. Next slide, please. So just a very brief trip down memory lane here to explain how we got here. So Google Quick added versioning pretty early on in its history, and a little bit later to avoid downgrade attacks. Well, sorry, because they had multiple versions, then it needed version negotiation, and then to avoid downgrade attacks, it eventually added downgrade protection. So all this happened like around 2013, which in Quick is ancient history. And the original IETF Quick drafts, because they were pretty much like trying to explain how Google Quick worked at the time, they initially had that feature. The nice, Lucas. The issue there is that this was like designed in a way that worked for Google's deployment, but that not everyone deploys software the same way that Google does. And so in issue 1810, which if I recall correctly was filed by Kazuho, he identified that if you have a server deployment where you have different versions rolling out at different times, or like a multi-CDN scenario where you could have some of your fleet support some versions and the other ones support other versions because they're like maintained by another vendor, this downgrade protection feature could actually fail connections that should have been valid if you end up like hitting one side, getting a version negotiation packet, hitting the other, and then getting confused because the other doesn't support the same ones as the first one. So at the time, because we really wanted to make progress on the Quick core documents and not get blocked by these design issues, the decision of the working group was to remove version negotiation from the core documents and say that this would be handled by an extension. And so Ecker and I in early 2019, then published this as an individual draft, which then early 2020 was adopted. And here we are. So next slide, please. All right, so as we were saying, the core documents are out the door almost. What do we have right now in the spec? So in QuickV1 and in the invariants, we define the format of a VN packet, which is a server to client packet saying, here are versions I support. And in the core spec, it says, if you receive this during the handshake, you abort your connection because it means that the server doesn't support your version, but you don't retry with another version because there's no downgrade prevention system. If your implementation only supports QuickV1, that's fine, because if the server you're talking to doesn't, or the peer you're talking to doesn't support V1, well, you're done. But as we're moving forward, like, people are going to want to work on different versions of Quick, so we might need something. In particular, one of the reasons this isn't too bad is that for HTTP3, this doesn't matter, because HTTP has alt service, and you don't use Quick unless you've gotten alt service, and that's already told you what Quick version your server supports. So you're going to use that version, and it's going to work in asterisk in most cases. But Quick is a general purpose transport protocol, and not every application is HTTP3, so we do need a robust version negotiation mechanism going forward. And another requirement that got tacked onto this draft is the idea that spending an entire round trip to negotiate the version is a lot of wasted time, and it would be nice if we didn't have to do that in most cases. So this is what this draft does. Next slide, please. So the draft introduces two types of version negotiation: incompatible and compatible. So the incompatible one is the simplest. The client sends its first flight, the server doesn't support it, it can't parse it, it just sends a version negotiation packet, and the client restarts with a new version. Next slide, please. And the other mechanism, which we call compatible version negotiation, is the one that doesn't cost a round trip, and that requires some properties on the versions, but it allows the client to send its first flight and the server to seamlessly upgrade to a different version. And so the idea there is that if, let's say, for example, the client supports QuickV1, QuickV2, but it doesn't know what the server supports, and like QuickV2 just shipped, and we know that way more people support QuickV1 than QuickV2, it'll start with QuickV1, and then the server, based on the initial, could say, oh, actually, QuickV2 is better. Let me seamlessly reply with QuickV2 because I still understand QuickV1 and can transfer that to QuickV2. And in particular, one of the neat things is if we look way, way, way down the road, you can reach a point where the server doesn't necessarily need to fully implement QuickV1 anymore. This still works if the server just needs to be able to parse QuickV1. Well, the first flight from QuickV1, which is initial packets. Next slide, please. But what is the property that we need here between the two versions if we want this compatibility to work? So we define in the document the concept of a compatible version. And what that means is, as you saw from the previous slide, is that you can take the first flight from a version and transform it into a first flight from the second version. So like in that example, QuickV1 is compatible with QuickV2 if the server can take a QuickV1 first flight and say, oh, let me flip a couple bits, and this is now a QuickV. I'm going to parse this as a QuickV2 first flight and just respond as if I had received that. So the conceptual thing is you apply a transformation from one first flight to another. In practice, that transformation might be as trivial as simply saying, oh, well, imagine that the version in the long header was the other version because the first flight format is the same. But we kind of left that open-ended because it allows, let's say, if for example, Quick v2 wants to change the format of the crypto frame, you could say, well, I received a Quick v1 initial, but I'm going to probe it and modify it. So here's how it looked with the new format of crypto frames with Quick v2. A note is that this compatibility relationship between version is not bijective. So it's possible that version A is compatible with version B, but not the other way around. Because let's say if a version is a superset of another, you can transform in one direction, but maybe not in the other. Another point is that then we define in the document the concept of compatible first flight, because if version A is compatible with version B, maybe some first flights are compatible and some are not. So an example is, let's say you add a new frame whose contents are absolutely critical, but don't exist in the other version. You could say, well, if you send a first flight without that frame, then it's compatible, you can switch it. But if it has it, then it's not. And so then you can, on the client, say, oh, well, I'm hoping for compatibility from the server. I'm not going to use this new frame. And therefore, because I didn't use this new frame, I'm going to be able to ask for compatibility from the server. And now, how do you ask for this? What does that mean? Next slide, please. So what, and one of, something I did forget to mention is between like last month or so, we completely rewrote the document. It didn't actually change the wire format or the mechanism in any way, but it tried to explain things better. And in particular, the mindset of the document is now to have something that speaks to the quick invariance, and then as an example tells you how it would work in Quick v1. But the idea would be that if Quick v2 is very different from Quick v1, but it'll obviously still follow the invariance, like this document still makes sense. So we have something that we call handshake version information, and both endpoints send this during the handshake. In practice, in Quick v1, this is a transport parameter. The reason for that is that is our best extension point for the handshake in Quick. And additionally, it is authenticated because it ends up in the TLS transcript. And so that is one key required property for downgrade attacks, is that for future versions, they need to make sure that the handshake version information is authenticated. And so how does it work? What does the client send? So it sends the currently attempted version is just a mirror of what's on the log header. So that doesn't provide any useful information, but what it does is it forces the value in the log header to show up in the TLS transcript to prevent an attacker from messing with it. Then the previously attempted version is in the case of incompatible version negotiation. So you're sending a first flight after you've received a version negotiation packet. You say, oh, by the way, I initially tried that version and you told me it didn't work. Again, this is to prevent downgrade attacks. And then it also has it copies the contents of the version negotiation packet it receives, which is like the received negotiation version. And the idea there is, again, to put that entire payload of the VN packet into the TLS transcript in order to make sure it is authenticated, so an attacker cannot miss with a single bit of it. Some folks have said on issues that it's kind of overkill, and it is. I think we could probably get the security properties with a little less information, but in my personal opinion is getting these things right is always tricky. So going with the let's just authenticate everything makes it safer, because it means it's harder for us to get it wrong. Like we can't have confusion attack because there is something we forgot to authenticate. And then finally, the last thing the client sends is the list of compatible versions. So in my example earlier, when the client sends its Quick v1 first flight, it would say, oh, and by the way, I can seamlessly upgrade to Quick v2 if you want to do that as well. So like this first flight is compatible with Quick v2. then what does the server say in response? The server will, so the negotiated version is again echoing the what it's sending on the long header, similarly to make sure it lands in the transcript. And then it also says, and by the way, here are all the versions I support. So the idea there is if there are versions that are not compatible, so let's say the server also supports Quick version 42, and that is so different from Quick v1 that it's not compatible, that it can tell the client, and the client can save in a cache somewhere, oh, this server speaks Quick v42. Next time I connect, I'm maybe going to try that. So like if your client already has an alt service cache, for example, that's kind of the same conceptual thing where it would put this. So the next time you want to talk to the server, instead of saying, oh, let's just use Quick v1 because I know most people support this, it's like we can use Quick v42, which is amazing. And the way downgrade prevention works is on the server, and this is a difference from what Google Quick did and what the original IETF specification did, but it allows for multi-CDN or gradual deployment in servers where, let's say you have a server fleet where you support a set of versions and you're going to change that to a new one. What you do is first you roll out a change to your entire fleet to say, as part of your downgrade prevention, accept these two sets of versions, like either the old one or the new one. Then you gradually go from the old one to the new one. And then you can switch for downgrade prevention, okay, all my servers are supposed to support this. And if something doesn't match that, then I declare the downgrade attack. Or similarly, if you have multi-CDN, you can say, I support this, and the rest of the fleet can also support that. So you can put that in your in the state. So that puts that responsibility on the server, because it's the server's job to know what its fleet situation is. The client has no idea. The one downside here is the client can't perform as much validation as before, and we're relying on the server to do their job correctly, but I think that's a reasonable design choice. And next slide, please. So this is the one point that kind of sparked some of the design, and I wanted to make sure we had it discussed and ideally reach consensus on a given design, because that way we can, if we're going to change that design decision, we need to revisit some design choices. So the question is, where can compatibility be defined? So right now, one of the features of the current draft is that compatibility can be defined anywhere. So let's say Quick version foo and Quick version bar are defined by two independent groups of people at the same time, and they don't know about each other, and those versions come into existence. It's possible for like a year later someone to write a document to say, oh, actually foo and bar foo is compatible with bar, and here's how you do the transformation of a first flight from foo to a first flight from bar. That isn't necessarily a critical feature, because in practice, I think most, like when Quick v2 comes out, for example, probably as part of that work, we'll say, well, and Quick v2 is compatible with Quick v, or Quick v1 is compatible with Quick v2, and vice versa, and here's how you do the transformation in both directions. But that might not always be the case. But what does that mean in terms of like the impact on the draft to have to decide the decision? It means that the client and the server can disagree on whether two versions are compatible, because if the document got written later, it's possible that the client knows about it and implemented it, but the server doesn't. So it's possible for the client to say, hey, here's an initial version foo, and also I'm compatible with version bar, and for the server to say, oh, no, I'm not compatible. I don't think foo is compatible with bar. So what happens if they disagree? If the client doesn't think it's compatible and the server thinks it's compatible, that's a trivial case, because the client just doesn't add that to the compatible versions, and the server will just treat it normally of, oh, okay, you think this is compatible with this list, do I have anything in there? yes, no. So that case is easy. The case that is also slightly trickier is if the client thinks it's compatible but the server doesn't. The solution is not hard. If the server, in that case, it kind of goes back to the incompatible mode. So if the server understands the original version foo, then it just negotiates foo and you're done. And if it doesn't, then it sends a version negotiation packet. So all in all, I think that the impact on the design isn't too big and that this isn't too complex, but I wanted to ask people what they thought here. And given that this is my last slide, next slide, please. All right, and that's kind of it. We think the, yes, Ecker, or I guess just before, we think the document is getting to be in good shape, but we want to hear feedback from folks. And also we're going to need more implementation and deployment experience. We haven't implemented this in Google Stack yet, and that's my fault. So we're going to try to get to that pretty soon. We don't want to ship this without implementing it first, but I would love to open the floor to anyone. Please send questions, comments. Do you think this draft is getting close to ready or not? Martin?
Oh, just before we get to the queue, we've got some people in the queue. We've got about 6 minutes for any discussion on this document. So I encourage people to get in the queue now, and we'll run the timer down. So.
Said in chat, and you know this, I think this is the wrong design. So I don't think this is it already. I think we need a much simpler design than what you presented here. I realize this is the maximal design, and you expressed a willingness to look for something that's a little more manageable. I think there is a more manageable thing here that doesn't require probably about half of the fields that you have here, and I'd like to explore whether that's possible here. I also think that there's a lot of work to be done on getting the transformation between two versions working properly, at least at a theoretical level, so that we can understand what's going on. Because what actually has to happen in practice in a lot of cases might be that the version 2 thing that offers a version 1 first flight will have to apply some of the constraints that apply to 2 to its version 1 flight, such that it can be transformed. And I don't think there's anything in the draft that currently addresses that particular concern.
So thanks, MTU. Before you go, when you say you want a simpler design, do you have something in mind? Because I'm totally game for simplifying things, but I would love to see a proposal. Like, are there specific simplifications that you can think of without losing features? So those we would definitely get. Or do you have features that you want to drop that might allow us to simplify the design? In which case, which features are those?
So just very briefly, when it comes to version upgrade, the principle that we've always applied is that the client offers a list and the server chooses, and that can work here. And when it comes to incompatible version upgrade, you just invert that, which is that the server offers a list and the client chooses. And I think that gets us 90% of the way to having a functional and secure upgrade system. And you've got a bunch of extra stuff in here, I think probably from the basis of an abundance of caution, which is probably fine. But I think we can probably do a little bit of paperwork and reassure ourselves that a lot of those fields aren't really necessary.
Okay, thanks. Chris?
Yeah. You mentioned a couple of times that this is perhaps somewhat complicated, and I was wondering, I'm not going to weigh in on the complexity point right now, but I was wondering to what extent this has been analyzed. I was sort of triggered with my ECH hat on in terms when you mentioned things like downgrade attacks and whatnot. And can you speak to that?
Oh, absolutely. There has been exactly zero analysis of this, apart from me looking at it and being like, this seems fine. And so therefore, it must totally be fine, right? Disclaimer, I'm not a security expert. So yes, we would before shipping, definitely want to have folks look at this. And in particular, one of the reasons for adding the version from the long header in here did come out of security research folks who were saying, oh, here are some fields that an attacker might muck with. And so in the quick core documents, for example, that's why we added the connection IDs to transport parameters to put them in the TLS handshake transcript. We need to do the analysis here to make sure that it does its job. From reasoning about it, I think it's fine. But again, like I was saying, I didn't do any kind of formal analysis, and it would be nice for someone to do that. I just don't have the expertise.
Nothing seems obviously wrong. We can probably assist with that, so we'll follow up offline.
Awesome, thank you.
We're at 2 minutes, so cut the queue after Dan.
All right, Ecker.
Hi, Eric Muscorola. I don't know what the authors of this draft are thinking. Sorry, I'm an author of this draft, so that was not intended to knock on David. Yeah, I mean, I think David and I talked about this separately. I think there maybe are 3 issues here. One issue is, do we actually need all the functionality that this draft provides? Namely, do we need both compatible and compatible? I think my opinion is widely known that we don't need incompatible, or we could define it later if we absolutely had to, which after all is the posture we took with Quick v1. The second question is this the right interpretation of compatible? Namely, transformable versus valid? So in the other protocols I'm familiar with, the definition of compatible is mostly valid. So like when you send, so as a concrete example, in TLS, the TLS 1.3 client hello is a valid TLS 1 client hello, assuming of course you offer TLS 1 as a version. So that's a simpler kind of concept. I think we should probably get away with, but we could discuss. And the third question I think is, given these sort of functional constraints that this draft adopts, is this the simplest design that provides the security value that you'd like to have, and the functional constraints as well? And I think that's the part I guess I'm a little unclear when Martin's challenging just this last point, or they're challenging a number of other points. So I'd probably helpful to drill down on later. But I agree this is like extremely complicated design, and so both it's worth asking: A, are these the right functional requirements, and B, is this the simplest way to get them?
Totally agree. That makes total sense, and I encourage anyone who thinks this is too complicated, which I don't disagree with, to propose alternate designs, because I think that would help inform the work here to come up with something better. Mike?
So I think this basically comes down to what restrictions we intend to place on future versions of Quick. And if we intend to put more restrictions on them than we have, we'd better do it in a hurry, because we've already sent invariants to the RFC editor. The trouble here is we've defined the invariants to say, once you get to the version field, that defines everything else that is in the packet. It might or might not use TLS. You might or might not have heard of it. You can send a greased version with completely incomprehensible payload, and all of that is legal per the invariants and stuff we've already said. I don't think we have the choice to go back on that now, and to me that means we can't really toss incompatible version negotiation out. And I think that probably was the right design. Now, does that make this complicated? Yes. Are there things we can simplify about this? I'm not sure. It'd be nice, but I don't think the path to simplification is retroactively changing the invariants to, you always have to know about all previous versions. Versions are linear. Versions use TLS.
Thanks. No, I totally agree with you. And even just saying all versions use TLS is like a non-starter. We still have Google Quick with Quick Crypto in production, and that is a real version. And we do have a mechanism, like we will at some point, deprecate and remove this version from Google servers. And we need a way to send a version negotiation packet to the client and that to fall back gracefully without downgrade being possible. So totally agree with you. There is absolutely a need for incompatible. One thought that comes to mind is we could end up splitting this into two drafts. One being, how do you secure incompatible version negotiation? And one is, how do you do compatible, which is trickier and more complex. That might be a way to simplify this corpus of work. DKG?
Actually, Christian, I think.
Yep, I'm just placing the queue for Christian.
Yeah,
Christian?
thanks, Dan. I mean, Dan did go in the queue because, I mean, the tool would not let me in the queue for some reason. Let's have a strong voice for simplification. Basically, I don't see how I would implement the current draft until it is simplified. So, in my mind, version negotiation, I mean, first, this is a security feature, and there is no such thing as very complicated security features. And the other thing is, I mean, it's supposed to be simple. I mean, the client is going to say, hey, I propose these, I would also accept that, that, and that, and the server might just pick one. And if it is more complicated than that, then we have lost. And I understand the fact that the server might want to say, oh, you did not tell me about version 42, but I also support version 42 if you want to use that next time. But that's something different. That's something that comes in a different kind of parameter. It's not negotiation, it's information.
Absolutely, yeah. I kind of shoved that in there because I could, but I agree with you that could be removed and put as a completely separate draft. Yeah.
So I think there's
thanks.
Clear consensus, at least, that there's a lot of desire for a simpler thing. And as David said, if you have simpler ideas, please propose them, because they will not arise. A simpler design will not arise from the vacuum.
Yes, and I really want to insist on that. I failed to come up with something much simpler and without dropping features, and I totally understand, but please come and let's have the discussion on the list or in the issues about which features you think aren't useful, and we can remove to simplify the design, and which design proposals you have that also make things simpler. Would love more participation. All right, thanks everyone for your time.
Thanks, David. Martin Duke, please step up.
Good day, everybody. I'm here to talk about QUIC-OP today, and just the TLDR here is that we've spent a long time thinking about use cases, sort of brainstorming, came up with lots of different options and different pros and cons, and that's kind of reaching the limits of that. And in some sense, that means we're ready for working group last call, but in another sense, there's some sort of high-level meta questions that we should address. Next slide. So I'm going to spend a little time today maybe giving a little bit of a primer to people who have not been paying attention up to now. Obviously QUIC is very opaque to middle boxes, including middle boxes that you want to have help you, like load balancers. And so there's a few, there's basically two main things here. One is how to encode stuff in CIDs for the use of those friendly middle boxes. And the other thing is how to encode stuff in retry tokens if you have some sort of the QUIC equivalent of SYN cookie offload. Because obviously the retry token, the retries packet design is resistant to just injection retry packets, and you just need to have stuff to allow that validation to work correctly. Next slide. Okay, so let me start with retry services. This is a little more straightforward. So there are basically two modes here. One is that one is a non-shared state one, which is what it implies, that other than the fact that the retry service exists, the server doesn't need to know anything about what's happening there. And the idea here is that servers will not generate retry packets under any circumstances. And the service is fully responsible for generating those packets and also authenticating them on the ingress. The shared state has more flexibility in its use model, where in theory retry packets can be generated by either the server or the retry service, and there's some more shared state there where you have to, distribute keys and so on. Since the last, since IETF 109, this has been pretty substantially revised thanks to Christian to improve the security properties of that token. The stuff in green there is relatively newish. The other thing is we've clarified a little bit the handling of unsupported versions. The retry service text used to say that retry services must admit all unknown versions, which obviously is good from an extensibility perspective. Not necessarily something would really happen in the real world. So in an effort to be a little more realistic, we've suggested that servers should be able to control the allow or deny list of versions. So if they are deploying, say, version 2, and the retry service, which might be in hardware, does not support version 2, they can say, no, let in version 2, but you can drop anything else, which hopefully is a little more economically realistic. Next slide. Okay, CID encoding. So this is kind of the heart of the document. There are a bunch of different things here. One is linked self-encoding, which is mainly meant to assist hardware offload of crypto, because CID lookup without knowing the CID length is kind of hard, according to the hardware people I talk to. Excuse me. There's some management of key rotation and config changes, and there's a fairly stable design for that, where the first 2 bits of the CID indicate the corresponding configuration. And so, when you're rolling out a new config, the load balancer is for a while speaking 2 configs, and then obviously the servers will be speaking one of those 2, and the load balancer is able to decode both of them. So there's kind of 6 possibilities here. We talked about handling lots of use cases and brainstorming and so on. So there's 6 possibilities. There are 3 algorithms. One is just simply taking the server ID and just putting that in some known bytes in the connection ID. And then there are 2 encrypted versions that obviously provide more privacy, more security of the server ID mapping. And many times before, I've given a talk on why it's maybe okay to not have perfect security here, because there's no such thing as perfect security when it comes to server ID mapping. I didn't repeat the slides in the order of time, but if we want to talk about that, we can. But we've reached fairly, certainly in the past, we've had a lot of discussions of these 3 algorithms, and I think there's been general agreement that those are correct. What's new is the server ID allocation mechanism. So up to now, up to IETF 109, you would manually configure a mapping of server ID to server. And obviously all the servers would have to be issued their bespoke server IDs. Now that is somewhat laborious, and Ian Sweat proposed a different way of doing this, which I've called dynamic allocation, where essentially new packets come in from clients with client-generated CIDs, and the load balancer does whatever it wants to get that to a server, and then both the load balancer and the server infer a server ID from that packet, and we'll talk about this more with another slide. And then for some time after that becomes an allocated server ID for that server. So the idea is that you do not configure server IDs a priori, you just kind of learn them over the course of operation. And that has some drawbacks and some advantages to it. Next slide. And so that mechanism could be used with any of the algorithms, give you kind of 6 permutations of CID encoding. Okay, so this is maybe talking to the server ID case more. So we have a situation here where the load balancer starts with knowing that there are 2 servers out there, but has no server IDs in its table. Similarly, the servers have no server IDs in their list of authorized server IDs. Next slide. So the reason not to do this, of course, is that static config the reason to do this is that static config of individual server IDs can be sort of a pain, but this does create a little more state, as you'll see, and it has an unfortunate corner case, which is not catastrophic, but I'll show it here in a minute. So let's say that we have a packet that comes in, and again, so everyone's on config 0 since there are a bunch of code, there are 2 bits to configure these configuration code points. So a packet comes in with config 0, and it like if you decode it, it comes out with the server ID. And so the next slide, and so the load balancer will just sort of make an arbitrary routing decision with this one, and send it to ABCD. So now both the load balancer and the server, by extracting the server ID, will recognize that 3FA1 is now allocated to ABCD. Next slide. So then some other time, another initial packet comes in and and when you decode it, the server ID comes out to be 2B0. And again, there's an arbitrary choice, and it goes to ABCD. So now there are now 2 entries in the table, and ABCD can use either server ID to generate its own connection IDs. Next slide. Okay, so one problem we run into is if we get, since the client connection IDs, the client generated destination connection IDs are essentially random, it could correspond to a config code point that doesn't exist in the actual infrastructure. And I've thought a lot about cute ways to do this, and I don't think there's a way to resolve the ambiguities here. Next slide. So what's going to happen is this is going to be routed, say this will be routed to EFGH, and there's no way to extract a server ID for this one. So really one of those 4 config rotation code points is reserved for tuple routing, just in case everything sort of falls apart. There's just something you can do there. So really in this case, EFGH, because we just started up, we have no allocated server IDs. There's really no way to proceed except to use the configure ID, the connection ID that tells the load balancer to use 4 tuple routing for that one. So this is a fairly transient state. Once something comes in, next slide. When something comes in with config 0 that happens to get routed to EFGH, next slide. Then there will be something in the table, and then the server will be able to replace all its CIDs. So given like a decent amount of volume, once you have, on the order of 4 initial packets come in, after restart or whatever, a server should have a server ID allocation it can use. So this is probably not a real practical issue, but there is a weird corner case here. So you'll note the state issue that instead of having approximately order of the number of servers entries in the server ID mapping, the load balancer has over time essentially the 2 to the number of bits in the server ID that's storing in a table. Now Ian says that Google does something like this in their current deployment, and that the state there is manageable. So there's some implementation experience that indicates that this is a manageable load. Next slide. So the dynamic allocation method is currently in the editor's draft. Just I thought it was easier to talk about that way, but I think that's something we still open for discussion. We can talk about if that's something we're supporting, if we want to support both methods, if we want to just go to dynamic because nobody likes static, something to discuss. The other open issue that needed some discussion was another one of Ian's suggestions, and today's server ID length is arguably a bike shed, but server ID lengths are currently expressed in octets. We could express it in number of bits, which would allow some bytes to be dedicated to the server ID and some of them not. There are certainly cases where you only need a certain amount of entropy in server ID, and you might cut a byte off the CID length, which is kind of nice. But it's yet more complexity, bit boundaries versus byte boundaries. Having tried to implement some of the stuff, it seems like that would be a bit of a pain to rev, but if people really like this, we can do it. Next slide. All right, so I would like to stop here and just take some discussion on these points. The other thing I'll add is I've actually attempted to implement both static and dynamic. Static's been around for a while. I know how to do that. The dynamic one does add some complexity because to preserve the ability of new servers to get server IDs, what I've added to the design from what Ian initially submitted was some sort of timeout, where eventually if a server ID has not been used for a while, kind of goes back into the pool for reallocation. And that raises some complexity where you really have to look at packets, and once you've already sort of made a load balancing decision, you have to look at packets and see if the server ID's been used and update the time you last saw it and so on. And The implementation I did was based on Nginx, where once you do the allocation, like it remembers the for tuple, and so you're having to wake up for every packet instead of really only when the for tuple changes, which is a bit of a bummer, but not insurmountable. So is there anyone in the queue that has comments on any of this? I guess not.
If your raise hand button's broken, we can accommodate you.
Ben?
I'm sorry, Lucas?
Ignore me, just carry on.
Okay.
So I worry that there are too many options here. I wonder if it would be wiser to pick one that we really think is the safest option, and in each of our different categories here, and recommend those, get some implementation experience, and see if the other ones are really needed, or see if the problems that arise are the ones that we expect. Maybe there'll be unexpected problems instead.
Yeah, Lucas, can you go to the next slide? You're kind of just leading right into the next thing I wanted to discuss. Right, so this is, so as I said, these drafts have really gotten to the point where we've reached the limits of just sort of brainstorming about use cases and different requirements. And really, to me, the real obstacle now is implementation. And I would hope that that would provide some insight into what Ben is saying, is that, like, what do we really need here? So these are the known implementations. Two of them are mine. One is just a library to allow you to, like, encode and decode server IDs. And I just lost the slides. Another one is, again, an Nginx-based implementation of the load balancer / retry service side of this. And I did a bunch of work on this last week, so the slide is a little out of date. The only thing that is missing that is currently in the draft is the shared state retry service, which I was going to try to tackle after 110. Also, Alipay did some work on this. It's a little obsolete. Well, it has the plain text load balancer, which is fine, and then it has an obsolete version of the shared state retry service. That's the only real interest I've had in people putting this to code. I focused on the load balancer because, you know, the load balancer community is not really here, and the server community is. So what we could really use is somebody with a server that supports mobility to implement the server side of this and do some interop. And if there was a lot of this, it might make clear what people actually care about and what is not a useful use case. And I would really, that's really kind of where we're at. Where I don't know that we can make a lot more progress on this document without this. And I stand ready to interop with people that want to test this out.
Thanks. I also want to highlight that I have some privacy concerns here. I think that some of these approaches have excellent privacy properties, and some of them have really poor privacy properties that essentially break guarantees that QUIC has previously made. I think that we should be very cautious about making recommendations in standards track documents that violate the security and privacy properties that we've promised in other standards track documents, especially because the load balancer and server are usually relatively closely coordinating entities. And so they require less standards guidance if they really want to go off and do something on their own. I think that in general, we should try to stick to the safest options. And if people want to do something unsafe, they can probably manage it on their own.
Are you referring specifically to the plain text CID algorithm, or are there other ones that you have concerns about?
The plain text algorithm is definitely the thing I'm most concerned about on that front. But I also would like to see some thought put here into how this interacts with ECH. It seems to me that there's a non-trivial interaction between QUIC-LB and ECH. In general, for an ECH QUIC implementation, with the split mode architecture, it seems like ECH processing is something that has to be somewhat coupled to the QUIC-LB handling. and it seems like it would be relatively easy to break the guarantees of ECH in the process of implementing QUIC-LB.
I would be I'm not going to be able to reason about that in real time, but I would welcome a discussion either the GitHub or the list of that to try to explore that a little further, because I certainly would not want to break ECH. Speaking about the plain text thing, I mean, I think that's a reasonable concern that's been kind of floating around from the beginning, because this design has existed from the beginning. I think there's been a lot of interest in supporting it from the QUIC community, which is generally very sensitive to these privacy issues. And one of the things is that depending on exactly what the statistics are of how many clients there are and how many servers there are, there's no way to guarantee that the server mapping does not become evident. And so people have tended to view this as a more of a continuum of privacy rather than a like private, not private duality. So nevertheless, that's a good comment, and I think it's absolutely worth discussing if we still have consensus that the plaintext CID algorithm should be in there. Other comments? Okay, so I just, again, I'd like to sort of say that I think this document is stuck until we get maybe some more reviews and particularly some more implementations to go forward. I don't feel really comfortable going to the last call and with the current implementation state of this document. So thanks.
Thanks, Martin. I think that brings us to the end of our main agenda items with about 9 minutes to go until the end of the session. We have some wrap up we need to do. I don't know if there's any time to talk about either of these documents. What
I think we can, what Laura suggested and what I think is worth doing, for people that are familiar with these documents, this is the quick bit greasing and both the delayed act. We're going to run 2 polls to say, we're not going to officially say whether we want to adopt these.
So given that we can't actually formally adopt anything at the moment anyway, because we are not rechartered yet, I think wasting time on running the polls doesn't make sense. I think we should just tell people that these documents, to many that have expressed an opinion in the past, seem like no-brainers for adoption. They're both sort of reasonably widely implemented already, and they have seen quite a bit of discussion. So we plan to hold adoption calls for those in the near future after recharter. And so you can prepare yourselves for that call by already giving them a read. And I would sort of, unless Martin or Jana want to quickly talk about each of their documents, I would maybe go to the planning and wrap up now already. Or Martin makes a good point in Jabber that so if people disagree that either of these documents is sort of ready for adoption, now would be a good time to raise those objections or concerns.
I'm just popping up here for no good reason, except to respond to questions. Christian, we're not talking about the timestamp draft.
Christian says, what about the timestamp draft? Chris, you want to talk about how widely implemented it is? I think it's in a different class than the other 2.
Yeah, it's less implemented. There are fewer implementation than for the other 2. That's clear. On the other hand, I mean, it's quite useful, and it's very simple. I know of at least 2 implementations, so it'd be nice that we had some visibility of that, some higher visibility of that in the working group.
Fair point. Let's then put that on the agenda either for an interim or for 111. But these 2 particularly looked quite uncontroversial, which is why we had listed them here. So I don't see anybody coming up to the queue to disagree that we should run an adoption call for those when we're rechartered. So I guess the plan is to do that.
The other thing we sort of discussed in the back channel here between the chairs is that version negotiation seems like it might need more face time. And so one way forward would be to see if we can do an interim on version negotiation between now and 1.11 in order to give people some more time to discuss this. Is that something we should plan on doing? David says it sounds great.
Anyone besides David who
Sean says yes
on
in
it.
all caps. Nick says yes. Okay, so it looks like sort of there are people that want to go forward with that. So we probably do a doodle poll for a slot and see when we can have it. I would sort of work from people in different time zones. Right. Matt and Lucas, is there anything else that you guys want to discuss as part of the wrap-up? Future meetings, I guess we will continue to meet at IETFs and we'll continue to do interims when we need them. Implementation drafts, we are on the final one, hopefully, for a while, which is the one on version 1. And that's the etc.
The only thing I can add about Qlog in this session. So this is a draft that we are considering adoption of based on the rechartering activity. So it's there, it's in holding effectively until rechartering completes. But in case you haven't yet seen any of the presentations Robin's done throughout the various other sessions at the IETF, he's given some overviews to other groups that might be interested. And you might remember that there's the concept of a main schema and then a quick and a H3 profile over that. But in the first instance, we'd probably be looking at doing Qlog in this group and working with some others to understand their needs. That then the whole thing could be kind of generalized and worked on elsewhere if people would be interested in the far future.
Yeah, it's surprising that this is the one session where Robin didn't present. But if you look at the charter proposal text, right, sort of it talks about a logging format, which we lumped in with the operability and manageability topics because it sort of belongs there. And that text is there because we as Lucas said, we assume we're going to adopt part of the Qlog work here, specifically the one that's related to QUIC. So we have 3 minutes. Anything quick that anybody else want to bring up? Otherwise, we'll go to Gathertown early.
The only thing I'd like to do is to thank our note taker or takers for helping out for the session. Yeah, and thanks for the healthy discussion as always.
Talk to you guys later. Bye.